Hello. In this video, we're going to learn about sketching exponentials. Now, we spent a lot of time solving exponentials, but it's interesting to look at the graph. What would the equation y equals 2 to the power of x look like? Now, naturally, if we want to sketch this, we're going to need a table of values, because we don't yet have an idea of any kind of base graph. So we're going to start with x and y equals 2 to the x. And like any good table, we'll do -2, -1, 0, 1, and 2. Just pick some basic values. Let's do the easy ones first. 2 to the 0 is going to be 1. 2 to the 1 is 2, and 2 to the 2 is 4. Now 2 to the -1, that's 1/2, or 0.5. 2 to the -2 is 1 over 2 squared, so that's 1 over 4, or 0.25. So if we plot these on a graph, we have 2 and 4, 1 and 2, 0 and 1, -1.5, -2 and a quarter. And so naturally, if we connect the dots, we'd have something like this. And I think to the right here, it's pretty clear it goes up, but to the left, does it make a parabola shape? Or does it kind of look like a polynomial? Does it go down? It's hard to say, but let's think about a really large negative x value. Like if we had -100. Well, then we would find 2 to the -100, which would be 1 over 2 to the 100, which would be a very, very large number on the bottom. And 1 divided by a very large number is going to be close to 0. In other words, as we go really far negative, we just get closer and closer and closer to that x-axis. In other words, we can put an asymptote at y equals 0. This horizontal asymptote will help us as we sketch these exponentials, because it tells us that we're going to approach that axis sort of like a reciprocal function. All right, so we've got a horizontal asymptote, and we've got this kind of shape going up. Over here, this side, this is often called exponential growth. Exponential growth. Because what happens is first it's 1, then it's 2, then it's 4. The next number would be 3, and 2 to the 3, which would be 8. And then 4 would be 16. And it would just keep doubling and doubling, and it would grow really quickly. It would grow exponentially. So we call this exponential growth. All right, let's do another graph. Let's have 1 over 2 to the power of x. Now, this is kind of neat. We have the same idea of some base raised to some power, but this time the base is a fraction. Is that going to change things? Well, let's see. We have y equals 1/2 to the x. So again, we do -1 or -2, -1, 0, 1, and 2. 0 is probably the easiest. Anything to the 0 will be 1. 1/2 to the 1, that's going to be just a half. 1/2 to the 2 means we get a quarter. Oh, it's kind of like the opposite. 1/2 to the -1 means we flip it and make it a 2. 1/2 to the -2 means we flip it and then square it to get 4. So if we go ahead and plot these, we'd have -2 and 4 up here. -1 and 2, 0 and 1, 1/2 and a quarter. Now we'd notice right away that we again have that horizontal asymptote at y equals 0. It helps our graph be nice and distinct. And we can draw a line like that. Okay, now if you notice for this graph, it starts off with maybe a large value over here, but as you go to the right, it gets smaller and smaller and smaller. This graph is called exponential decay. This shows up in many other areas, as we'll study later when we do some word problems. Exponential growth on the previous one has to do with things that really get out of control. You can think of like a bacteria infection, where the bacteria are doubling and doubling and doubling. Or you can think about compound interest, where you're making interest on your interest and your money's just growing and growing. Exponential decay is kind of like the opposite. It's like you have something big and it's going away faster and faster and faster, and before you know it, it's all gone. Exponential decay is generally used in physics when we talk about radiation and radioactivity. But it's anytime you have something that's disappearing and it's just petering out really quickly. All right, let's look at another graph. Here we have y equals 3 to the x. So I'd encourage you to pause the video and give it a try. See if you can get a basic sketch of y equals 3 to the x. All right, so again, we're going to use a table of values. So we can just do them right on the graph. 1, 2, negative 1, negative 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when x is 0, y will be 1. When x is 1, y will be 3. When x is 2, y will be 9. Then here we'll have 1/3 and 1/9. It's kind of hard to draw 1/9 on here. I might just skip it. We're still going to have, though, if we see from the graph, a horizontal asymptote at y equals 0. Sketch the graph like this. And there we go, our exponential. The important thing for the exponential is that you always include the horizontal asymptote. All of these basic exponentials will have a horizontal asymptote at y equals 0. And they all have sort of this same shape where it sort of starts off low and then swooshes up really fast. But obviously, we can't leave it there. We have to do some transformations. And so, let's sketch y equals 2 to the x plus 3. Now, I'd encourage you to pause the video, give it a try. You can use a table of values. I mean, you can also use transformations, but you can use a table, you can use whatever you want, but we need a nice sketch of this graph. All right, so let's go ahead and try a table. We're going to do the same thing where we have negative 2, negative 1, 0, 1, and 2. Center it around 0. Now 2 to the negative 2 plus 3. Well, that looks messy. Let's come back to that. 2 to the 0 plus 3 will be 1 plus 3, which is 4. 2 to the 1 plus 3, which is 5. 2 to the 2 plus 3, which is 7. Okay, so we've got some nice points over here. 0 is 1, 2, 3, 4. 1 is 5. And then 2 is 7. Now it's hard sometimes to draw an exponential. The right side, I think we're good. But over here, it's like, where do we swoosh to? And that's why we need this plus 3. The original horizontal asymptote was at 0, but now since we've moved the graph up, a vertical translation of up 3, the old asymptote that was here has now been moved up 1, 2, 3. So we're going to have ourselves a horizontal asymptote at y equals 3. And I mean, there you go. You don't actually need these other points. You could skip them. As long as you've got 2 or 3 points, your graph will be good enough. And the asymptote will help provide that definition on the left side. All right, here's another one. Y equals 3 to the x plus 2 minus 4. Again, please pause the video and give it a try. If you're looking for a hint, this means the horizontal asymptote will be moved down to y equals negative 4. So assuming you gave it a try, when we go to make our table, this is just a little bit tricky. Because of that x plus 2, if we were to do, let's say, 0, 1, and 2, when you plug in 0, you actually get 3 to the 0 plus 2, which is 2 minus 4. Now that number is not terrible. 9 minus 4 is 5. It's all right. But the next number is going to be 3 to the 3 minus 4. That's 27 minus 4, which is 23. And the next number is 3 to the 2 plus 2, so 3 to the 4. That's 81 minus 4, which is 77. These last couple numbers here, 23, 77, honestly, they're too big. they're too large to really sketch on a graph. And so unfortunately we only have like 1 point right now. We've got 0 and 1, 2, 3, 4, 5. Now, we do have a horizontal asymptote, I guess, at -4. But I mean, 1 point in a horizontal asymptote, that's just not enough to get a nice defined sketch. So, I mean, we could try over here with the -1. That'll give you 3 to the -1 plus 2. So that's 3 to the 1 minus 4, which is, so 3 minus 4, -1. Okay, that's a bit better. Then if I do -2, that's 3 to the 0 minus 4. So 1 minus 4, which is -3. All right, now I feel more confident with that graph. I think I've got enough points that I can get a good shape. Oh, let me just try to go through that point again here. So I think that looks pretty good. But if you notice, it was actually these points that were useful. These ones were the ones that were useful. On the last one, the negatives weren't useful. And you might be like, hey, what gives? Well, because of this +2, what happened was the graph actually was moved left by 2. And that kind of means that your whole table sort of has to be shifted left or right. Now, you don't have to do it like that. You can just sort of make some random numbers and hope it works out. But if you're going to shift the x values left or right, I would highly encourage you to shift your whole table just so you're kind of targeting in on the sort of the center, if you would, of that graph. If the center's been moved left by 2, you got to be careful that you're not picking points too far over here, because these are so far to the right of the center that the graph is just crazy high, right? 23 and 77. All right, go ahead and graph this function. Y equals 1/4 x minus 1 plus 1. Okay, now the plus 1 here means we have a horizontal asymptote at y equals 1. Because of that -1, that means we're going to move it right by 1. So right by 1 unit, that means instead of doing maybe -2, -1, 0, 1, 2, I'm going to move everything right along the x-axis. So I'm actually going to go -1, 0, 1, 2, 3. So I'm going to move it right by 1. Remember, the table, you get to pick your own x values, and I'm just going to pick ones that are to the right a little bit higher. All right, let's go ahead and start. I think 1 is actually kind of the center, because when I take 1/4 to the 1 minus 1, well, 1 minus 1 is 0. So this is 1, because anything to the 0 is 1 plus 1, which is 2. Okay. Let's throw that asymptote on here. Let's, at 1, got 2. Add 2, 1/4 to the 2 minus 1. So that's 1/4 to the 1, which is just 1/4 plus 1. So 1 1/4 or 5/4. So just a little bit above 1 over here. Maybe let's go back to the 0 here. This will be 1/4 to the 0 minus 1. So that's 1/4 to the -1. So we flip it to be 4 plus 1, which is 5. So over at 0, it's up at 1, 2, 3, 4, 5. Now with those 3 points, I think we're good to go. So we're going to connect the dots. And we've got ourselves our graph. All right, so some notes on this. We are sketching exponential functions. And the basic method for this is a table of values. Table of values, which is really a good method for any graph. But with the table of values, we want to keep in mind transformations And in that sense, we're kind of thinking about the base graph. So this is the base graph for an exponential function. Let's say y equals 2 to the x. When you do a table for the base graph, if you want to do just the most basic table, you do -1, 0, and 1. That would give you a half, 1, and 2. That's like the most, like the minimum number of points you could use. And then you'd have here 1, 2, and a half. And you'd sketch it like this. So here's your like minimum number of points. And of course you have a horizontal asymptote as well as your additional feature. So these are your minimum points. And there is your asymptote. And that's like the absolute bare minimum you would need to sketch a graph. And so you should keep that in mind when you're looking at something else. For example, why don't you sketch y equals 5 to the x minus 10 plus 3. So notice we're going to have an exponential of base 5. And we're going to be looking for where that horizontal asymptote moves to and where that minimum number of points, kind of like the min points, or maybe another way of writing it here. We could say this is like the, your base points. Basic points. Where are those basic points going to be located? Because I think the x value would be a bit different because of that -10. So go ahead and give that a try. All right, so the horizontal asymptote will be at y equals 3. So on our graph here, 1, 2, 3. And then for our points, we're probably going to pick x values centered around 10. Because it used to be centered around 0. This is kind of like the center. And so now the new center will be over here. Okay. When we plug in 10, 10 minus 10 is 0. So 5 to the 0 plus 3, which is 1 plus 3, which is 4. So over here on the x-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 and 4. Then when you do 11, you get 5 to the 11 minus 10 plus 3, which is just 5 to the 1 plus 3, so 8. So over at 11, we've got 4, 5, 6, 7, 8. And then at 9, well, we're going to have 5 to the negative 1 plus 3, so 1/5 plus 3. Oh, that's gross. What is that? 16/5, I guess. So just a little bit above 3. And there's our graph. All right. So you can go ahead and try one on Unit 8, Worksheet number 5. And then any things to remember. Again, some of the terminology we used was exponential growth and exponential decay. Hopefully you enjoyed this video, and as always, thanks for watching.